Welcome to The Explainer. Look, when we think about modern sports, we usually just picture the star athletes, the blinding lights, and the roaring crowds, right? But behind the scenes, modern infrastructure is actually undergoing this quiet, highly regulated green revolution. Let's dive into the fascinating, entirely unseen mechanics of building a massive, eco-friendly sports complex.
25,000. That is the seating capacity of the Maharaja Yavindra Singh International Cricket Stadium in Mullanpur, Chandigarh. Now, just picture 25,000 passionate cricket fans pouring into a single location on match day. Building a stadium capable of safely hosting that many people is a monumental task on its own, but doing it sustainably, that requires a completely different level of engineering. We're talking about a 300-crore project here, and as we're about to see, designing a venue on this kind of scale means meticulously accounting for every single drop of water, every watt of electricity, and honestly, every speck of dust.
To make sense of how a mega project like this actually comes together, here's our inspection checklist for today's explainer. We'll start with the new stadium and the environmental rulebook, then look at mastering water management, powering the pitch, and finally building responsibly. Let's get right into it.
Section 1. A new cricket stadium and the environmental rulebook, the bureaucratic reality. Okay, so at first glance, this probably just looks like standard dry government paperwork. It's a half-yearly compliance report from December 2025, submitted by the Punjab Cricket Association. But you really shouldn't think of this as just bureaucratic red tape. This document is actually a meticulous, legally binding environmental rulebook. The state-level Environment Impact Assessment Authority dictates exactly how this stadium must be built and operated, literally down to the smallest detail. You don't just get to pour some concrete and start selling tickets anymore. You have to prove, twice a year, that you are actively protecting the local ecosystem.
And these mandated construction constraints brilliantly illustrate just how strict this rulebook is. The builders couldn't just use standard materials. They were mandated to use fly ash-based concrete blocks to drastically reduce their environmental impact. Every bit of topsoil they excavated, it had to be carefully stored and reused for the stadium's own landscaping later. Inside, the stadium is required to use low-flow plumbing fixtures and a dual plumbing system. They even have to color-code the pipes, blue for fresh water, green for treated reused water, and yellow for discharge. It's like a giant color-coded puzzle. And throughout all of this, continuous monitoring of ambient air and noise levels is required just to ensure they stay within prescribed government standards.
Moving on to Section 2, Mastering Water Management. Mastering Resources.
So, the crucial point here is understanding the absolute extreme fluctuations a stadium experiences. The numbers reveal a staggering shift. On a standard, non-match day, the facility generates about 48.8 kiloliters per day, or KLD, of wastewater. But on a match day, when those 25,000 fans actually arrive, that number skyrockets to 300 KLD. That is an enormous surge. If a stadium of this size just dumped that matchday volume into the local municipal sewer system all at once, it would completely overwhelm the town's infrastructure, no question.
So, to solve this, the engineers had to get a bit creative. They installed a sewage treatment plant right there on the project premises. But the plant's capacity is only 100 KLD. So how do they handle that 300 KLD matchday spike? Well, the answer lies in buffering. They built two massive 200 KLD storage tanks. During a match, all the excess untreated effluent is stored safely in these tanks, and then it's slowly, steadily fed into the 100 KLD treatment plant over the following days. It's an incredibly elegant, highly controlled solution to a massive logistical nightmare. And here's where it gets really smart. Let's look at how this plays out in daily operations. Once that water is treated, it doesn't just go down a drain somewhere. It is dynamically reallocated based on the season. Flushing remains constant at 2.8 KLD all year round. But in the intense heat of the Indian summer, 25 KLD is dedicated solely to gardening to keep the grounds alive. During the rainy season, nature does the watering for them, so the gardening allocation drops to just 5 KLD, and the surplus is redirected to broader irrigation purposes. Literally every single drop is accounted for and optimized based on the weather.
And check this out. This commitment to water conservation started long before the stadium was even finished. Tankers were delivering treated sewage water directly to the construction site. Why? Because the environmental clearance strictly prohibited the use of fresh groundwater for construction activities. All the concrete mixing, all the curing, all the heavy construction work relied exclusively on treated wastewater brought in from outside treatment plants. It's definitive, visual proof of the rulebook in action.
All right, Section 3, Powering the Pitch. Energy Demands. Think about a stadium packed with tens of thousands of cheering fans, massive floodlights blasting, broadcasting equipment, giant screens. It requires an immense amount of electricity. To help offset this incredible demand, the project includes a proposal for a 1,326 kilowatt solar power generation plant.
And the solar initiatives don't stop there. The compliance rules explicitly mandate that at least 30% of the open rooftop area has to be utilized for solar panels to capture maximum solar energy. They're also required to use solar lighting in common areas and rely on highly efficient CFL and LED lighting throughout the whole complex. And because power outages during a live international broadcast are simply not an option, they have heavy-duty diesel generators on standby. But even these are highly regulated. They must be housed in specific acoustic enclosures with regulated exhaust pipe heights just to prevent noise and air pollution from disturbing the surrounding area.
Which brings us to Section 4, Building Responsibly. Impact Management.
We saw the crazy water fluctuations earlier, right? Well, the solid waste numbers are just as extreme. On an off day, the stadium produces a very manageable 36 kilograms of trash. But on match day, that number explodes to an absolutely staggering 3.86 tons of solid waste. Imagine nearly 4 tons of plastic cups, food wrappers, and organic waste generated in just a matter of hours. It's wild.
You literally cannot simply dump 4 tons of garbage into a local landfill every time a cricket match ends. So, the compliance report outlines a super strict waste management plan to handle it. It starts with source segregation, separate wet and dry bins everywhere. But the really impressive part is the mechanical composter. All the biodegradable waste, like leftover food and vegetable scraps, is processed right there on site through mechanical composters. The recyclable materials, papers, plastics, glass, they aren't just thrown away. They are systematically collected and sold to authorized recycling vendors. Only the inert, completely non-usable waste actually makes it to the municipal facilities.
But building responsibly isn't just about managing the waste of the final product, it's about minimizing the absolute chaos of the construction itself. The rulebook demands strict procedures to protect the neighboring communities from the dust and smoke of a mega construction site. This includes mandatory wheel washing for all vehicles leaving the site so they don't drag mud onto public roads. They must install perimeter screens and barricades, use enclosed debris chutes rather than just dropping materials, and ensure every single truck bringing in sand or loose material is fully covered with tarpaulins.
Finally, we gotta look at the human element. A project this massive requires a massive workforce, and the environmental clearance mandates strict standards for their care. Photographic proof submitted to the government shows a dedicated first aid room and sanitary washroom facilities built specifically for the construction laborers. The rules actually dictate that the project must provide safe housing, fuel for cooking, safe drinking water, and even medical health care for the workers right on site. It's a holistic approach to sustainable building that includes the well-being of the actual people doing the heavy lifting.
So, what you should really take away from this is that none of what we've discussed today is optional. As stated right in the general conditions of the report, proper records of compliance must be maintained and made available at the site at all times. This isn't just some PR promise they made before breaking ground. It is a legally binding, continuously monitored reality. Government officials can inspect the site and demand to see the logs for the electromagnetic flow meters on the water pipes or check the acoustic compliance of the generators at any given moment.
Which leaves us with this final thought to chew on. We all love the spectacle of a massive stadium on match day, but the footprint of that entertainment is just colossal. As global mega stadiums continue to grow in both size and cost, is this kind of incredibly strict, microscopic environmental playbook the only sustainable way forward for the future of sports infrastructure? Honestly, it definitely seems like the days of simply pouring concrete and turning on the floodlights are far behind us. Thank you for joining me for this explainer, and keep questioning the mechanics of the world around you.